Welcome students, this is your review video for our second 6 weeks test number 1. We're going to take our test on Tuesday 10/20th, which is our next class period together. For this review you need to write down all of the things that are in here on separate notebook paper or just plain white paper and bring that into class on Tuesday. Alright. Direct variation, the main things you need to know about direct variation is that it's an equation that's in the form kx, so y equals 3x. It's not going to have anything on the end of it. As far as the picture, it is a straight line, and the straight line goes through the origin. So it can go up, it can go down like that, it can go up that way, but it has to be a straight line and goes through the origin. And we solve these problems through the use of a proportion. So if somebody gives you a problem like, let's just say that your points per game are directly proportional to the number of minutes you play. So if Mr. Ashcroft plays 10 minutes and scores 15 points in a game on Monday, and on Friday he expects to play 15 minutes, how many points can he expect to score? This is a proportion. So you would set up, we like to set it up in words first, minutes over points. So 10 minutes is 15 points equals 15 minutes over blank points. We cross multiply. 10 times x is 10x. 15 times 15 is 225. And then when it's beside it, we divide it, so I divide both sides by 10. And x equals 22.5. So if Mr. Ashcroft plays 15 minutes, he can expect to score around 22.5 points. Okay? So directly proportional. It doesn't matter whether it's x's and y's or real world problems like this. We set up a proportion, we cross multiply and divide. Okay? And even if you want to do it like you did back in middle school where you just do 225 divided by that 10 over there, you'll still end up with the same answer. Right. Transformations. So the transformations we talked about were like making the graph steeper, making the graph flatter, making it go downhill, uphill, and then we talked about sliding or translating the graph up and down. Okay? So all of this was in reference to y equals mx plus b. The m did three things. If we made m a negative number, that made it go downhill. Okay? So if we had y equals x, the parent function, that would go up like this, but if we change it to y equals negative x, that reflects it and makes it go down like that. Okay. Number two, if we make it a bigger number, and that makes the graph steeper. And when we say steeper, if this is a line, then this line is steeper. Okay. And then the last thing is if we make it smaller, that line would be flatter. So flatter would be if this is our line, flatter is going to be closer to 0, flatter like that. The b does all of our translations. So if we add a b, that translates it up. If we subtract a b, that translates it down. And if we have no b, then it's at the origin. It has not been shifted. Okay? So if I put y equals 4x plus 3, if you look at that, you know that's been shifted up 3. Alright, domain and range. So domain is x, range is y, vector xy. We have two types of domain and range. If we're given ordered pairs, like 1, 2, 3, 4, 6, 7, then our domains are all of the first numbers. So our domain would equal 1, comma 3, comma 6. And our ranges are all the second numbers. So our range would be 2, comma 4, comma 7. Okay. This is if it's discrete, which is just points listed. If it is continuous and on a graph, then we might have something like that. And if that's the case, this is where, for our domain, we do left to right. And so it's all about what number does it hit here and what number does it hit here. So let's just say, for example, that this hits at -4 and +4. Then our domain is -4 to +4, x in the middle. We always start with less than, since these have black dots, and we put our lines under them. Okay? Then our range, bottom to top, so we'd see how low does the graph go, so it's associated with that number, and then how high does the graph go, it's associated with that number. So our range, let's pretend like that's -3, and that's +5. So our range is -3 to 5, range is y, less than, less than. Since it touches, put the line under it, black dot, put the line under it. So this is what domain and range looks like for continuous. Okay. Solving, draw our line down. We always look for parentheses first, so here's some parentheses. So that's 3x minus 3 because we multiply. 3 times x is 3x, 3 times the -1 is -3. Then we go to the other side. Nothing has to be done on the other side. So now we have x's on both sides, so we can't have x's on both sides, so we've got to get rid of the one on the right, because remember I like to have my x's on the left. So I minus 2x from both sides. 3x minus that is 1x. Bring down my minus 3 equals, those cancel out. Bring down my 3. Box my x, add 3 to both sides to get rid of that. Those 3's cancel, and I get that x equals 3 plus 3 is 6. Okay. Over here, very similar idea. Draw our line down. We have x's on both sides. I don't want x's on both sides, so I'm going to get rid of the 3x on this side. 5x minus 3x is 2x. Bring down your minus 2 here, bring down your greater than symbol, those cancel out, bring down your 12. Box your 2x here, plus 2 to both sides, plus 2 to both sides, those cancel out, 2x is greater than 12 plus 2 is 14. When it's beside it, you divide it, so divide both sides by 2. You get x is greater than, just greater than 7. Okay. Sometimes they'll ask you about possible answer choices that would fit into this inequality. So they might ask you, is 6 a possibility? So then you would plug in 6 here. Is 6 greater than 7? No. They might ask you about -1. Plug it in here. Is -1 greater than 7? No. 10. Is 10 greater than 7? Yes. The only other thing that can happen in inequalities is, remember, if you get down to the end, and let's say you had -2x is greater than or equal to 14, when you divide by a negative, you have to flip your sign. So x is greater than, or x is less than -7. So it's just that right there. If it's a negative, you have to flip your sign. Okay. Alright, standard form. When we talked about standard form, we did it with the purpose of finding the intercepts. Okay? Remember we said if you cover up, if you take -2x plus 2y equals 8, if you cover up the y, then what you're left with is the x, and if you divide both sides by -2, you find out the x-intercept is -4, because 8 divided by -2 is -4. So that means this crosses at 1, 2, 3, 4. It crosses right there at -4. If you're finding the y-intercept, -2x plus 2y equals 8. To find the y when you cover up the x, that means you're going to divide both sides by 2, and you find that y is equal to 4, so you go up 1, 2, 3, 4, and there is your y-intercept. Draw your line down, so that would make your line right there. Okay. So this would be 0, 4, and this is negative 4, 0. This one is also known as 0. This one is also known as the b. So things kind of have some different names for them. From here, you could actually count out the slope. Your slope is up 4 over 4. So your slope here is 4 over 4 or 1. Okay? You have some other options here. You could take these 2 points right here and stack them and then do stat edit. And if you do stat edit, that would give you your y equals equation for you. And so that's one of the ways you can take something we learned earlier in the year, standard form, get yourself 2 points from it, and do stat edit. I'll do stat edit on my calculator real quick. Stat 1, negative 4, 0 on the left. So this would be my L1, and this would be my L2. So 0 and 4 on the right hand side, stat calc 4. And so I find out that the equation is y equals 1x plus 4. There's your 1 for your slope. There's your 4 y-intercept that was down there. Functions. The main thing about functions is that the x's can't repeat. Okay, so in all situations, you're looking at the x's. So if you have ordered pairs, then you're looking at that front number. Those don't repeat, so that's a yes. If you're looking at a table, right here, 1, 2, 3, 5, that's a yes also. If you're looking at a mapping, it's 1 arrow out, so that's a yes. If you have a sideways table, the x's are always on top, y's are on the bottom, so 1, 2, 3, 5, 6, 7, 11, 12, 13, 14, 15. So again, 1, 2, 3, 5, 6, 7. This is a yes because those are all different numbers. So it's x's, you can't repeat. You can't repeat with a different y. If we're going to do function evaluation, so we're given an f of x, which is the same as y, and we're given x squared minus 6. So this is basically y equals x squared minus 6. And we want to do for an f of negative 2, so that's f of x. So they're telling you that x equals negative 2. Right? So the way I like to think of it, if you have a table, x is negative 2, we're looking for y. So I take this, type it into my calculator into y equals. Then I hit second graph to get the table to come up. Then I go on the table and I find my negative 2, and we find that that also goes with negative 2. Okay? There's some ways you can plug in and stuff, but I still feel like using this y equals in your table anytime you have this f of x stuff is much easier. There's much less risk in doing a problem like that. Okay. If I'm trying to find the slope or the y-intercept from a table, I'm always taking these and doing L1, L2. You push stat 1 to get to the table. Once you get the table, you enter in the x's on this side and the y's on this side. Then you push stat again, your right arrow. You go down to number 4, which says LINREG, that stands for linear regression, and then it's enter 5 times. When you hit enter 5 times, it spits out your equation right there. A is your slope, B is your y-intercept, and then your equation is 2x minus 4. Okay. Remember, we've had a few times where we did our stat edit, and we got A to be something like 1.333333 all the way across the screen. Remember, to do that, you have to go on the home screen and type in 1.3 all the way across the screen. Okay, when you get it all the way across the screen, then you push math 1 enter, and it'll tell you what that is as a fraction. 1.3 all the way across the screen is going to do 4/3 for you. If you get stuck on something, you have questions about that, just feel free to ask on the test. Ask if you ever have calculator issues, just let us know and we'll work with you. Alright, so bring this in. We're going to do a little bit more review work in class, and then hopefully you'll be ready for your test and for your district checkpoint.